Hello everybody, this is a tutorial on how to improve VIS drift tracking when the VIS drift tracking in automated mode has not performed very well because of too faint of a VIS image field, which we will be exploring with the dataset shortly. So the settings for automated VIS tracking, which is the normal mode, which CCD Lab will be installed with, is under the UVIT menu, create drift correction list from int mode frames. That's what the visible channel is, integration mode frames. And then we see that it defaults to the point source track. And there's a couple of options here. So no drift series plot confirmation just means that it won't plot the drift series track for you and ask you if they're okay. It'll just skip that part. And here, no PSE confirmation means it will just automatically pre-select, do point source extraction on the visible image to determine sources to track, and it will just automatically proceed with those. And you can turn that off if you want. So if you want to go to manual mode, what you do is you uncheck that. You do want PSE confirmation. That means point source extraction confirmation. You do want to do that yourself. And you also do want to do plot confirmation. So you would check that off and check that off. However, what we will do is keep those on for now, and I will demonstrate to you how we can see that the VIS tracking is not working all by itself. So let's go ahead and proceed with all of the default settings on a L1 archive. So we need to go to desktop here, and it's right here. And this is the file, and we click open and proceed. So we will just let it proceed up to that time, and I'll do a little fast forward here now to the VIS tracking. All right, so now the VIS tracking is attempting to proceed by itself. That track was okay, but look at this. When you see something like this, obviously that was a problem. So you can see that there's real problems. It's tracking this bright source here automatically by itself okay, because it's nice and bright, but it's trying to pick up faint sources. That's really the only source. And in this case, for this image, it has only found two sources, this one and this one. So it automatically asked us to select sources ourselves, because if it finds only two sources, it's going to assume that there's a problem, that the sources are simply too faint. So now it actually has asked us to select a source. So let's just select that one and continue. We know that it can track that bright source, okay? So here it found three, so obviously those two. Now, of course, you have to be watching this, in the current code implementation. You watch it and you see if there's problems like that, and then, that's how you would sort of know. Now, obviously, for the end user, what I should have done, and what I can still do, is I can code in a, just as here, how it found only two sources, and it asks us to proceed manually when it does that weird squiggle thing when one of the sources goes flying off. I can also code in, a self-detection for that scenario, and then it'll say, look, I'm having a problem. Would you please try to select sources yourself? That's what I should do for the end user, just that the end user would be forced to then to select sources yourself, just as it does when it finds only two sources automatically by itself, or two or less. But let's just continue assuming that it could run all by itself. So here's obviously a very bad track again. So we'll just run through this as if it's going through the automated mode, and we'll see what happens to the images when we have bad drift series like this, a series of bad drift series for all of these VIS orbit images. So it's applying those drift series now to the FUV images, and we should see a good fraction of these images, or these orbits, which did not have very good tracks, drift series tracks. They should be quite blurry. Remember, the first one worked by itself, if you recall, but then look at, see, does not look right. You can see that there's some problem here, obviously some problem. So A lot of these images did not have good tracks. I think this one looks like it worked okay. This one did not, did not, did not. This one's maybe okay, not. So obviously we're losing at least half the orbits here, just because in the VIS series here, the drift was just so poor. So if we go and open up, this is just for the user right now to see. You don't have to do this yourself unless you wanted to. But if we just go look at some random VIS directory here. So I just went to any of the VIS directories, VIS orbits. Let's just open all those. So it loaded 900 images. Let's just scan. So we can see that we have a very, very faint field here. There's really only this bright source showing up. You can maybe see some dim things around here, but those are very, very, very faint. Those are going to be quite tough for the tracker to track itself. The other problem you might notice is these artifacts. So this is the result of cleaning up the image of, these would have been major artifacts. These lines going across, these horizontal lines halfway across the field, these would have been major artifacts before the cleanup. They would have been very, very bright lines, which would have really, really destroyed the ability of tracking. They still show up a little bit because they can't be corrected out of the images perfectly, although they are corrected enough that, for example, if this bright source was moving around these, the tracker would still be able to track despite the presence of this low-level remaining artifact. However, when you have a very dim source like this that is coinciding with even these low-level artifacts, then that really harms the ability to track such a faint source that's crossing over these dim artifacts. And so that's why you get that strange behavior of those tracks flying across the image. And like I said, perhaps I can code in something that just says the program would be able to detect when that happens just by statistical analysis of what the track is doing, and then I could, warn the user to do it themselves. But it is a fairly rare thing. In any case, I'll show you for now what the solution is going to be. So let's go to UVIT, create drift correction list. We're going to use int mode frames. So what we want to do is check off this because we do want plot series confirmation. We do want to confirm that the plots look fine. And we do want to confirm that it has pre-selected good PSE sources for us, point source extracted sources for us. So let's just double click this, and we just click on the parent level directory VIS, and it's going to go through the whole list again for us. Okay, so we just click on the parent level directory VIS and select OK, and it's going to proceed. So it asks us, existing drift series lists found in all subdirectories. Do you wish to reprocess? Yes, we do, of course. So we click yes. So on this first image, it has found 5 sources for drift tracking. Do we want to let it go ahead with that? Yeah, let's give it a try. So let's select yes. So now it is going to attempt the track. And so we see that this one source gave a very, very bad track, and this plot does not look right. These lines should all be coincident with each other. Obviously, they've become quite separated because there's a major problem. So let's select no for redo. It's not okay. Let's select no. So because this is the very first folder we're still working on, we just select the parent directory again. Okay, so now it has asked us if it wants to use, or if we want it to use these 5 sources. So we selected no, we don't want it to use those 5 sources. What we want are sources that did work. So this source is okay, so we simply click there on top of that. This source was okay here. And let's just proceed. I think this one, you can see that there's a bit of noise in this source too. So let's leave that one out. Yeah, obviously that one does not look the same. So let's just select those 2, press yes, and it will proceed. Okay, so now we have, these are 2 curves on top of each other along with their mean, which you don't see because it's buried inside. So this one was okay. So now we select yes to continue. Do we want to proceed with these 3? We can try it. So we select yes. Okay, so that did not work. Okay, so this is not good. Do we want to proceed with those 3? No. Now we're going to select our own, so click there, and click this one. Looks like it gave an okay track. And proceed with that. Okay, now this plot looks good. These 2 plots in X and Y. So yes, continue. So again, we just proceed through this way manually. We can let it try with the 3 sources it has found and see what happens. So that did not work very well. Yeah, these plots don't look good, so no. that's no good. No, don't use those ones automatically. We will select our own, press OK. So this one is OK. And let's just use that. That's the only one we can use. Okay, yes, that's good. So again, we can let it attempt to use its own sources. No, that has not worked very good. So click no, click no. Yes, we're going to identify our own sources. We could attempt this source down here and this source down here, since we know that occasionally they give good tracks, and we could see what happens. Okay, so this one worked and the other didn't. So we can select no, press no. We don't want it to continue with its own sources. We will select them, so let's select that one. And this one, yes, proceed. Oh, no, this one didn't work. It worked at first, but now it didn't work. Okay, no. Okay, so only this bright one we can use. And again, it's because these faint sources are crossing over these artifact regions, which cause them to lose their tracking. If there were brighter sources here, it wouldn't lose tracking. It's just because these other sources are so faint that these artifacts interfere with the tracking and cause it to fly off the screen like that. So let's just continue with this one. Okay, yes, continue. We can let it attempt. Yeah, so those didn't work again. So select no, press OK. So we will just use this one. Right click, proceed. Yes. Okay, that didn't work, so we're going to go no. Click no, click OK. So click on that bright source and right click. So pretty much only that bright source ever works in this example of images. So yes, that one's okay. Might as well just press no because we know that almost never works. So we'll select that. Maybe we should try this thing here. Maybe that's bright enough. We could try this. Oh look, so that worked okay. There's a bit of a squiggle here, but that's just a very temporary noise. That'll actually get smoothed out from the interpolator. So yeah, why don't we just keep that? Use 3, we can attempt to let it try. No, that didn't work. So press no, press OK. So select that source, and it looks like this one did work. So select it. So right click, press OK. There, so that was a very short series, only 200 seconds. Yes, that one was okay. Again, we can attempt to let it use the first 3 that it finds. So what the algorithm does, it's actually finding the brightest sources above an internal threshold that it's using. So select no, select OK. So these other sources are the brightest sources. These are the ones that it's trying to use. These are the second and third brightest sources in the image. And so you can see that they're quite faint. So really, we only have this one good bright source in this whole series here. Okay, so select no, okay, but we know that this one is okay, so we click on that. We know that this one is okay, so we left click on that, and then right click to continue. Proceed, yes. Oh, now that one didn't work. Strange, right? Sometimes it does, sometimes it doesn't. So no, no. Okay, I'm going to try it again because it did seem to actually work that first time. Okay, now it did work. Okay, so select yes. No, don't proceed. Okay, we'll try that one and that one. Okay, you can see that there's noise here. That's okay. A little bit of noise like that is okay. It gets smoothed out. So yes, continue. So here it only found 2 sources, so it's asking us right away to select our own. So we'll try that one and that one again. Yeah, we can continue with that. Okay, this one failed right at the very end. So select no, select no. Okay, we'll just select that bright star only. Right click to continue. Okay, that will have to do. This one seems to work occasionally. Yeah, no, it failed there too. Let's see. Yeah, it failed. It looks like it failed and then it came back on track again, actually. Yeah, it failed and came back on track, but that's too much of a failure. That's too much of a deviation. So let's select no, select OK, and let's just continue with this one source. Yeah, so this is what would be considered a very, very difficult level of reduction, which normally you wouldn't have to do. Normally there are more sources in the viz fields. And normally you don't have these artifacts either, which conflict with these faint sources. So we can attempt these two again. Yeah, see, it failed the tracking and then it came back on track. So that's too much of a failure. Select no, select no. Okay, so we'll just select this breakpoint here. Right click and continue. Okay, so now we've gotten through all 16 folders, 16 orbits of viz tracking, and we found and we've confirmed them all. We've only accepted what we liked, and so now we have 16 good tracks and otherwise very difficult orbits to perform drift series on. Select yes, and now we'll re-proceed with fitting or with applying all of those viz drift series over to your centroids from your other images, from your science images. Okay, now if we flip through, we see that we have good images for every single orbit here. Okay, and this is quite a faint field. There's still not many other very good sources here. Well, maybe there is for registration. So I might as well just show you the rest of the procedure. So once we finally have some good drift series determined from our very difficult and faint viz orbits, viz fields, viz folders of each orbit, let's go ahead and do registration. So we know that there's a nice, good, strong point up here. So let's just start registering on that point only. Okay, that's the folder we want. Okay. Let's make this search box big enough. So this is the only bright source around here, so a nice big search box is fine. Okay, I selected it and right click, right click, right click, right click, right click, right click, right click. You can see that this box is finding the brightest source in the field here automatically by itself, because the translational movement between each orbit isn't that large. Okay, determine and apply. Yes, go ahead now. Okay, now we want to determine if there was any rotation between orbits. So to do that, you can either just blink yourself, pressing forward on your mouse, the forward button on your mouse, or by pressing this button here. Or you can scan. I prefer to scan. So we see that there is some rotation happening in a few orbits here. So we know that this is a good anchor point. And if we change the contrast settings to maximum, we say that this is the only point we can really see. So if we go back to dark, we just need to find some other point that looks like it would be a good point to track on. And probably this one would be the best here. That's actually a fairly decent point in all of the other images. So between this point and this point, we can determine registration to derotate these orbits. So let's do it again. Registration. General registration, we can leave this at 4. If the fainter sources were even dimmer, we might have to do binning down to 1/2 pixel resolution, but we can stay at 1/4 pixel resolution, as these images are actually at 1/8 pixel resolution. So staying 4 is okay for now. But if you needed extra signal to noise, you could change that to 2. So double click general registration. Yes, that's the folder we want. Okay, so this is our first point, since that was our anchor. So keep that being the first point, and this could be the second point. And that's all we need. So right click. Now, do we want it to run through automatically? No, don't run through automatically yet, because there is some rotation there, and we want to make sure that that rotated point is staying within each time. So click no. Yes, let's continue. Okay, so no rotation there, continue. No rotation there, continue. No rotation there, continue. No rotation, so right click and continue. No rotation, so right click and continue. No rotation. Okay, no rotation, so right click and continue. No rotation, right click, continue. Okay, so now we can see that there's some rotation. So this point will stay here, and we just need to rotate this one to be coincident with that point. So right click to continue, right click, continue, right click, continue, continue. So it looks like halfway through this series there was some slight rotation. A couple degrees only. Okay, this is the last one. So now we'll figure out that rotation for each orbit and derotate these images so that they're all coincident, collinear with each other. Good. Now if we scan, we see that we have very good registration here for this point that had been rotated. This point is lying on top of itself very nicely. If we look over here, there's no rotation happening. If we look over here, no rotation. So all these images are lined up very nicely. So now we simply do the merge. Oops. We do the merge with folder browse for most recent. Yes, so we double click that. So this is the folder that we want. That's the parent level directory. So it's combining all 16 orbits into one. And we get a final image, which is 22,669 seconds deep. Now we can actually improve the PSF for this image. So the PSF of this source is 1.78 arc seconds. So we can improve that by doing create drift correction list. From PC mode list, because we're going to self-optimize. So nothing should be checked here. These should all be unchecked because this is the source we're going to try to self-correct on, this bright source here. Let's do a stack time of say 7 seconds because it's a fairly bright source. And then we just double click this. Okay, now if we compare, yeah, we've gone down to 1.49 arc seconds. So we've optimized that, the PSF in these images somewhat. Okay, you can see some sort of interesting structure out here. Big galaxy. Anyway, then you would do the WCS solution. So we simply click Astro Query. We want a blue filter. RA point, deck point are the keywords. 17 arc seconds. 500 brightest points is good. So we double click that for Astro Query. Okay, and then we simply click solve. We might want to increase this to 100 points. And there it has got a solution. Yes, clear. Clear. There, now that looks more square. And if we go to UVIT and derotate loaded images based on that WCS, so now we have our final image. So we see right ascension increasing, 1259.30, 1300, 1330, 1301, and there's our declination. Okay, and then you would obviously just go and finalize your science product there. Okay, so hope that was helpful. That's how you can perform the VIS drift series tracking manually when you have a very poor VIS field for tracking. Obviously, you can always contact me and I can either process the data for you or I can help walk you through it over a Zoom call. And I hope you're all well. Take care. Bye-bye.